All right, welcome to 4.2 Patterns and Linear Functions. Our essential question today: how do you represent relationships in words, equations, and graphs? This is part one. We're going to do the words and equations part of this today, and then tomorrow we'll work on the graphing part of it. All right. So first off, talking about dependent variable versus independent variable, we need to figure out which thing depends on the other one. Okay, so this first one, temperature, time of day, which one depends on the other one? Well, temperature depends on what time of day it is, right? If it's nighttime, the temperature is lower. The temperature does not dictate what time of day it is. Age and weight, well, you can't really change your age. Your weight kind of depends on how old you are, right? Temperature versus time of year. Again, temperature would be your dependent variable here because it depends on what time of year it is. Height of the rocket, time after takeoff. Well, here the dependent variable would be height of the rocket because that all depends on, how high is the rocket? Well, how far after takeoff is it? The length of time filling a pool and the water level. The one that depends on the other is the water level because how full is the pool? Well, it depends on how long it's been filling. Okay, and the length of your hair compared to the length of the last, or since your last time haircut, sorry, it'd be the length of your hair would be the dependent one because it's depends on how long ago you got your haircut. So as you can tell, the dependent variable, that's the answer you get, and it depends on what you plugged in, and so we call it the output. Okay, it's what you get in return. The independent variable is you can just plug in whatever you want, and that's called the input, and then it spits out an answer, which is your dependent variable. So in our equation, which one is the dependent variable? Which one's independent? Your y is always your dependent variable, and your x is your independent. Okay, you can plug in whatever number you want for x, and it'll spit out an answer, right? And what y is, you have no control over it. That's dictated by whatever number you put in here, right? So, talking about a function now, just some vocab for you. A function says that each x has exactly one y. You can test that with the vertical line test on a graph. Here it only crosses one time, that's good. Here it only crosses the graph one time. Here it only crosses the graph one time, etc. Here would be the same exact thing. Crosses one time, crosses one time, crosses one time. If you get a graph that looks like this, all of a sudden it crosses twice. That's a problem. So this one would fail. But these two work, so they are functions. This one even works because the closed dot versus open dot. Open dot says this isn't included. It's up here. And so this actually is a function. It's called a step function. So just some different graphs that pass the vertical line test. Now this one does not work because the x value, each x has exactly one y. And here we see that 3 has two y's. And so this is not a function. Not a function. All right, a linear function, it's when you graph the function and you get a line. Okay, so if you get a line for a graph, it's called a linear function. The root word of linear is line, so it's a line function. Now, we're going to start working with some patterns of linear functions. This is just kind of introducing us to the concept of functions. Okay, so in this diagram, we need to figure out what is the relationship between the figure number and the number of squares in the figure. Okay, and so for figure number 1, we have 1, 2, 3, 4, 5 squares. For figure number 2, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. And then this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. So our variables, we'll probably F for figure number. And we'll say S for squares. Okay. Now, our job is to make an equation for this. Okay. Squares is our dependent variable because it depends on, well, it depends what figure we're talking about, right? And so squares is going to be all by its lonesome over here. And we need to figure out what goes on the other side. Now, a good rule of thumb is to just start trying to find patterns. Like, what happens between these two numbers? Well, here we add 4, right? So plus 4. What happens between 9 and 13? Well, we add 4 again. Ooh, that sounds like a pattern. And so, based off of what we know, this number right here is going to be what we multiply by. Okay, so it has a difference of 4, right? And so I know it seems like we're going to be adding 4, but actually it shows us that we need to multiply, and actually that shouldn't be x, that should be s, right? Oh, I'm sorry, f. Oofta. Alright, so we're going to multiply by 4. Okay, now that doesn't quite get us there, right? Because 4 times whatever figure number it is, so 4, in this case, 4 times 1 is just 4. But we need to get 5, so what do we need to do? Well, let's try adding 1. Let's see if that works out. And so when we go to check this thing, figure 1, so 1 times 4 is 4, plus 1 is 5. That checks out. Okay, 2 times 4 is 8, plus 1 is 9. Good. And 3 times 4 is 12, plus 1 is 13. Okay, and obviously you can check F and S. We have 1, 2, 3. It's always good to check. I'm not going to do it in the video because I'm going to conserve time, but you do need to check and conserve and just make sure it works. Okay, now we have the amount of water, Y, in a tank after X minutes. Okay, so how much water is left? I don't know. Depends on the number of minutes, right? So is the relationship a function? We need to ask ourselves, does each X go to exactly 1 Y? In this case, each X relates to exactly 1 Y. So yes, it is. Is the relationship a function? Yes. Okay, now we need to describe the relationship using words. So every minute the water, every minute, what happens to the water level? Well, let's just start subtracting here. We subtract and we get 12, and difference of 12, and a difference of 12. Oops. And it's minus 12, right? You know, if we were to be good about our sign usage here, minus 12, minus 12, minus 12. I know that's awful, but it does have the pattern of subtracting 12 each time, right? Okay, so what does that mean in our practical terms? Well, it means that every minute the water goes down by 12. Gallons. Now, it started out, whenever we have a time 0, that's our starting point. And so I'm going to jump down to our equation here. Our variables are y is for water, and our x is for time. Okay. Now, like I said, the water depends on the time, right? And so our amount of water, we started out at 440. Anytime you get at time 0, that's going to just be a number, 440 in this case. And then we go down 12. Now remember what I said, the difference here is going to be what you multiply by. So our equation would be 440 minus 12x. And again, it's always good to check to make sure it's good to go. Okay, same thing here. What happens between the two? Well, we add 3, right? Add 3, add 3. Cool. So y equals, now we started out at time 0, right? And so this number is our constant, so 5 plus 3 times x. This is the factor at which we multiply, so times positive 3. Okay, relationship using words, each time we increase by 3. Is the function linear? Okay, so does it go up? Basically ask yourself, does it have any, if it has like a square on the x, then it's a no. But is it linear? The x is kind of all by itself, it doesn't have an exponent, so yes, it is. It is linear. All right, that's it. No graphing for today. We're actually going to come back to the same exact lesson tomorrow, and we're just going to work on graphing. So there's your homework. No graphing today.